Hello everyone. We'll talk about conditional probability and complements. We'll begin with conditional probability. Conditional probability of an event. Okay, if something is conditional, that means there's restrictions on it or requirements. So that indicates that there's a dependency. You must do this to do that. There's a condition involved. So conditional probability means there's something required. There's a dependency. Conditional probability of an event is a probability that you calculate, and you have the understanding that it occurred because some other event has occurred. You can think of it as cause and effect. One thing led to another, or you had to have this before you could do that. You could look at it almost like a schematic, like a gateway. From here to here there had to be something, so in order to get here, something here had to occur, and so forth and so on. What it comes down to is that there's a dependence involved. These are dependent events. One is dependent upon the other whenever you do your calculation. And you'll look at some of the stuff that we look at and compare, and you can see, okay, yes, there's a cause and effect here. Sometimes it isn't. It's just the way that we choose to look at our data that causes there to be a dependence. So that's why we say that the probability calculated. Not everything will be to where because event A occurred, then event B can occur. So our formula for conditional probability is the probability of B given A. That tells us conditional probability, and it is simply the probability of A and B over the probability of A. And the probability of B given A means the probability of event B occurring given that event A has occurred. Given is your key word in your homework problems. So B given A. B given that A has occurred, and these are dependent events. So again, this is your formula that you will use. So pretty simple. You should know the probability of A, and then what you're looking at is an intersection, the multiplication rule of two events, the probability of A and B. So let's look at this as a visual representation. I think it helps to be able to see things in different ways. You can think of conditional probability as a ratio. B can be viewed as being a part of A. So you have A and B, that intersection, so they're intersecting, divided by the probability of A. Again, the probability of B given A. The probability of B given A. So let us look at an example. Here we have a table, and what's broken down for us is did homework, did not do homework, passed exam, did not pass exam. And I tried to use the same nomenclature instead of passed exam, failed exam. Getting to the statistics talk. So what's asked is find the probability of randomly selecting a student who passed the exam given they did not study. So pass the exam given that they did not study. So this is actually quite easy in how you approach working these problems, in that you're simply going to identify the keywords in your statement. So the first thing that we're going to do is we're going to mark the word given in the statement. So there you go. Now we'll use green because that's what I was using in the formula. And then to the left is event B. To the left of the word, because remember what we have here is that we have B given A, and that's the structure that your sentence will be in also. B given A. So B is past the event. It's to the left. This is B. And then what's to the right? Did not study. Or sorry, did not do homework. And that's going to be A. I now have my structure, my setup. I can just replace this with the words because to help me be able to visualize it. So I will simply say, because my formula is this, I'm not going to write it with the different colors. Probability of B given A is equal to the probability of A and B over the probability of A. So what I can just say is that what I'm looking at is the probability of pass the exam given didn't do homework. It's a T. Didn't do the homework. That's what I'm looking at. So I need to find the probability of A and B. A is did not do homework, so did not do homework, and B is pass the exam. So this is A and B pass the exam. I find where they intersect. And means intersect. Did not do homework, pass the exam. The number is 4. Over how many people didn't do homework? Or sorry, A, yeah, did not do the homework. So I look at did not do the homework and I take that sum, and that's 36. 1/9. Okay, so with this being said, is that okay? Well, the first thing that I did was I didn't sum my table, and I did that just for sake of time for y'all's video so we can work another example. But I'm going to rework this right now and show you that what I didn't do for this problem is actually have that denominator there that you can think of it as that can be there for this problem. So real quick, let me sum my table and then show you the second way to do it. And I'll show you why the first way is just a quick way and you don't have to worry about something. Alright, and this is only for conditional probability. So I have 1/9, and that's about 11%. Help you to be able to visualize it. It's hard to visualize 1/9, but 11%. So 11% actually passed the exam but didn't do their homework. So let us work it a different way. So again, I have the probability of A and B over the probability of A. So the probability of A and B, that's where A intersects B. A is did not do homework, that's A. B is pass the exam. Pass the exam, where they intersect is 4. So 4 over 134. 4 over 134 over, what is the probability of A? A is did not do homework, so did not do homework. Total of that, 36 over 134. For some of y'all, you don't like this. It is a fraction over a fraction. But I'll show you what I did. I just eliminated the denominators to begin with because I knew that that would happen. I'm going to rewrite this, and this is probably easier to see. 4 1/34 divided by 36 1/34. Dividing is the same as multiplying by the reciprocal. In school you were taught the little saying keep, change, flip. Well, most likely y'all were taught it. Really all it's saying is multiply by the reciprocal to do your division. So what this problem turns into is 4 over 134 times 134 over 36. The 134s cancel out. I'm left with 4 over 36, which equals 1/9. Okay, so again, either way that you choose to work it is just fine. With your conditional probability problems, because there is multiplication and division being the same, I can simply omit that summed total and be able to solve it just like I did up here. Place my values over each other. If you are not comfortable with that or cannot see that, then you can work it out as long as you're comfortable with a fraction divided by a fraction. Need be, rewrite it like this. Perform the operation, multiply by the reciprocal, cross cancel, simplify, same answer. Same answer. Alright, so one other example. For this one, I want you to pause the video. And sorry, I forgot to write the table in there, so I wrote it in there. Kind of small, crammed in there. But same data from the last one. And then what I want you to find is the probability of randomly selecting a student who did the homework given they passed the exam. Pause the video, work it, and let's see if we get the same answer. Okay, first thing I'm going to do is I'm going to mark the word given. And that helps me to visualize where is B and where is A. B is to the left, so did the homework, that is B. And to the right is going to be passed the exam, and that is A, passed the exam. I know that my equation for conditional probability, and what tells me it's conditional probability is the word given. So the probability of B given A equals the probability of A and B over the probability of A. So this is the intersection. And means intersect. So I find where A and B intersect on the table. A is passed the exam, so there's passed. And did the homework is B. Did the homework, it's 83. Over the probability of what? What is A? Pass the exam over 87. Let's see with our calculator, 83 divided by 87 is 0.954. 0.954. So about 95% passed. Again, working it the other way, if I turn around and I take my totals, 47, 98 and 36, and 134. Okay, if I take my totals and then I structure my problem like that, I end up with 83 over 134 divided by 87 over 134, which I can rewrite as 83 134ths divided by 87 134ths, which turns around and gives us the same answer. Again, whichever way is best for you to visualize the problem and be able to work it. Okay, so just to reemphasize, probability of B given A, probability of B given A. I find the word given. B is to the left of the symbol given, so the words, it's to the left. Did the homework, I identify that as B. The next one is to the right, passed the exam, I identify that as A. Once I do that, then it's a matter of just plugging in the values for each one. Okay guys, continue to watch your videos from the publisher. Structure, critically think about your homework, analyze what you're doing. Work the problems more than once if need be until you say, I know how to do that problem. Any questions, ask. Good luck on your homework.